click on record before we begin. Anyway, okay, good. So we're started. So sorry if you missed the original one. You're watching the recording. I missed like again the first 10 minutes. Okay, good reason for people to come on time, I guess. All right, here we go. So indentation. Indentation is absolutely critical. Okay, so I'm going to do is I'm going to run the program to show you that this actually works. So if somebody puts in a grade that's not more than 100, fine. Line number 3 is skipped. If instead I put in like 123, what will happen is the if statement on line number 2 will, of course, trigger true, which means that I do all of the stuff that's indented in order, followed by, of course, by the rest of the program. All right, now if I simply stick in the word hello right here, okay, and I put in the number 123, okay, well, that's going to change the value of grade to be 100. And of course, it's also going to print out hello. But if I put in a score that's okay, I still see the word hello. And that's because this statement right here is not inside the if statement. If you want it to be inside the if statement, you indent it. Okay, that's it. The indentation, by the way, is 1, 2, 3, 4 spaces. That's the standard. Okay, so a tab key will work in most editors. Okay, so there you go. That's how you decide what's involved. So there's no curly braces to decide what's inside an if statement. It's based on indentation. And actually, this is kind of good because the indentation is actually much easier to read than curly braces. The only thing that you can't do is you can't do kind of like some cutesy little shortcuts, but I think that's bad news anyway. All right, so there we go. That's the first one up. All right, second one up. Well, you know what? Maybe I need to do a couple of things. Like maybe if somebody gives me a grade that's less than 0, I want to make sure that the grade reaches 0. So I could use a couple of if statements. So if somebody puts in like a really big number, it gets capped at 100. If somebody puts in like a minus 98, it gets cut off to a 0. So truncation. So a couple of if statements. All right, so there's the first one. All right, second thing up. Um, Let's suppose that we just want to decide whether or not a student has passed or failed the course. All right, well, here's what I'm going to do. Instead of using an if statement like this, I'm going to use it like this. If the grade is bigger than, now for this course, it's a 70. Oh, but people, if they get a 70, yes, we still consider it a pass. All right, so if the grade is bigger than or equal to 70, well, then what I would do is I would say that the result is probably a pass. And of course, the exact opposite result is a fail. Mhm. All right. And of course, that's exactly what happens in this course is this ends up happening. So if you get an 87, say, in the final exam, it said your grade is 87. Wait, your grade is result, right? Okay, if you get an 87, yeah, it's considered a pass. I don't believe you actually get a grade. I think you just get a pass or a fail. And of course, if you get a 45, well, that's considered a fail. Again, you guys have been through programming courses before and other work done in programs, so I think this is not too bad. So of course, yeah, we have the if and the else. All right, now to involve ourselves with this, there's always a couple of extra things. Okay, our first one up is a pile of ifs followed by else. Now, this is going to be for the benefit again for those being through C++, Java, and JavaScript and PHP. All right, here we go. Let's turn the grade 80 into a letter grade. Okay, so here we go. Int letter. Okay, what I'm going to do is I'm just going to put a question mark for right now. It's just a placeholder, and I'm going to say, okay, if the score is bigger than 90, then the letter grade is definitely going to be an A. Now, of course, this is assuming something else. Else. Okay, else. The letter grade is equal to B? No, 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 no. Because what we need is we need another if statement. We'd have to say else, spell it correctly, else if score is bigger than 80. Okay, I suppose I should be less or greater than. Here we go. So it's an if followed by an else if followed by an else if followed by an else if. Okay, in the world of Python, it's a little bit funny. So here we go. If the grade is bigger than or equal to 90, then the result is definitely an A. And instead of having an if else, which by the way might end up possibly working if the grade is bigger than or equal to 80. Okay, see this one right here? No, you can't have an if followed by an else. You can't have an else followed by an if. There we go. That's the other one. Exactly the same thing. In order to deal with this, what they've done in the world of Python is they've made up this new operator, new keyword called elif. And that's exactly what it is. Okay, so here we go. That's a B. And let's do another one. Elif grade is bigger than or equal to 70. Then the result would be equal to a C. Elif grade is bigger than or equal to a 60. The result is equal to a D. This is our regular undergraduate scheme. And every other possible condition is an F. Oh, and yes, feel free to use single quotes, double quotes as you wish. My only comment about this is try to be consistent. Like what I've done right here is actually not good. I really should be consistent. Okay. I mean, if you make a mistake, it's not a big deal. Just when you notice it, go off and fix it. All right, so here we go. So if you put in something like a 95, of course, the first statement here on line number 3 executes. If you put in like a 65, this one would be skipped. Okay, since this is false, I would check this one, then I would check this one until I finally find something that's true. And then, of course, I would run this one. And finally, if absolutely none of them trigger or none of the ifs are true, then the result is simply the else case at the very end. Okay, so there you go. Exactly the same concept that you would see in these other programming languages. Okay, nothing unusual here at all. Sorry, just give me 1 second. Okay, that should be much better now. Okay, let's get over to my slides, and here you go. All right, so before I go there, and of course I say the block of code is controlled with indentation. There are no parentheses required, but indentation is used. So, okay, and again, here you go. Here's the examples. Do people put parentheses? And the answer is yes, and I will tell you who puts the parentheses. Students and professionals who come from C, C++, Java, JavaScript, and PHP will put parentheses because you're completely used to it. Okay, but my recommendation is when you're dealing with Python, just try to remember to leave them out. Okay, yeah, it'll work if you put them in, but it's just absolutely no need for it. Curly braces, on the other hand, semicolons, no. Well, the curly braces don't work at all. All right, so next one up. Okay, next topic. So one very, very quick thing. Oh, okay, nobody's tossed this into the chat window yet. There's always going to be somebody who comes over and says, okay, well, what about this? What about this thing called switch scorer? Okay, no, there's no switch equivalent in the world of Python. It's just a bunch of ifs and elifs. Okay, it's a little bit different. And sometimes I wish that they had a switch, but in any case, it's just a pile of ifs and elifs. All right, next one up. Okay, after ifs comes loops. Okay, and again, yeah, you guys have been through looping already, so hopefully this is really just a quick reminder of things along with the syntax. So my suggestion here, I mean, this came verbatim from my regular programming course, said, hey, if you wanted to compute a final grade for every student in the course, you could do it without loops. Yeah, you just copy and paste everything. Remember, we did an exercise yesterday where we were trying to get rid of digits out of a string, and I did a replace with 0, replace with 1, or replace with 2, or replace with 3, and I copied and pasted them. And I said at the time, generally, when you do something like this, it's usually a pretty good indication that there should have been a loop because you're probably looking for a pattern. So whenever you copy and paste code, you generally want to look for a pattern, and either the pattern turns into a function, which we will see by the end of class today, or you turn it into a loop of some sort. All right, but unfortunately, successful loop structures require pattern recognition, and to determine what needs to be repeated. These are the types of things where I find that intro students in particular, so you guys are not intro students, these are the things that everybody struggles with, because being able to observe a pattern so that you can use the same piece of code with slightly different values in the variables, that is incredibly difficult. But unfortunately, the reality is without loops, most programs wouldn't even be possible. And if they were possible, they'd be just monstrous in size. All right, so first one up. Okay, everybody coming from all the languages, so the usual C++, Java, JavaScript, and PHP, everybody knows about a while loop. Okay, so I don't need to go through and really describe everything, but of course I will do this just to remind you. A couple of changes. First of all, you'll notice that there is no parentheses, there is no curly braces. exactly like an if statement. You have the keyword while, you have the condition, and you have a colon. Everything else is indented. And of course, something that's very important is once the while loop starts, all the lines in the while loop go until you go back up to the top and check again. Okay, so there you go. You go through the entire thing unless you have a break or a continue, which we will see. I think it's later in this class. If not, it might be at the beginning of the next 1 hour. Okay, basically you go through the entire thing. So in order to get started, I wanted to break up about how you would use loops. So again, if you have been using programming, this won't be anything new. If it's been a few years since you've done any programming, maybe it's a good idea to remind you of something. So there are basically two types of loops that we end up covering in our intro programming course because these are the two things that show up all of the time. In fact, I suppose what I might do is I might pop open some actual Python code and we'll take a look and see if we can identify what they look like after we finished this lecture and the next one. I'll bring up some actual stuff that I use and we can say, okay, is that a counted loop? Is it one of these other types of loops? Okay, and yeah, they will probably both exist. All right, so a counted loop is a loop format where you repeat something a certain number of times and you know in advance how many times that you need to repeat it. All right, so here's what I'm going to do is let's get over to my interpreter. Let's write up a little program. Okay, so write a program that asks the user to enter 5 temperature readings because it is hot today. Here we go. 5 temperature readings. Display whether or not the temperature is hot for that day. Okay, temperatures over 40 C will be considered hot. Okay, there you go. There's my problem statement. Okay, so let's go off and let's write an application. All right, counted loops they always look exactly the same way. You always have some kind of a counter at the beginning. And the counter is almost always initialized to be 0. And by the way, this is not my program yet. This is just me getting started. You always have a while loop that says, well, the counter is less than the number of things that you want. And I'm just going to print hello for a second. And I'm going to say that the counter is equal to the counter plus 1. All right, if I run this program right now, just to remind you, you see what happens is it prints out the word hello 5 times. All right, it's because what I do is I print it when counter is equal to 0, when it's equal to 1, when it's equal to 2, when it's equal to 3, and when it's equal to 4. That's 5 times because the very first time was printed when it was equal to 1. All right, now a couple of things about this. Some people will end up writing counted loops like this. That would work exactly the same way. Counter is equal to 1 while counter is less than or equal to 5. But I usually find that life is much easier if you start them equal to 0. And the reason for it is think about the position of the very first character in a string is at position 0. In a list, the very first element is at position 0. That's why most things you usually start counting at 0 rather than 1. But yeah, it works. You can certainly have them start from 0. Now, this, of course, doesn't really solve my problem, but I got a couple things I want to talk about. This one right here, counter is equal to counter plus 1. Okay, everybody coming from C++, Java, JavaScript, and PHP will have looked at this and said, hey, bozo, you do that because it's easier. And you're right, that is easier, but unfortunately, it doesn't exist in this language. I don't know why they didn't include it. The closest thing that I have, you would also be familiar with, it's a plus equals. Okay, that means counter is equal to counter plus 1. Okay, so exactly the same thing. You want this to happen 10 times? No problem. You change the number to 10. Okay. All right, now let's get back to our actual program. Write a program that asks the user to enter 5 temperature readings. Okay, instead of counter, I'm going to use the word reading. Ooh, now reading. Now, reading 0, well, reading is less than 5. Reading goes up by 1. Now, here's what I would like to do. I don't want to print hello 5 times. I want to ask the user 5 times. So here's what we're going to do. Temperature, again, I really like longer variable names, not just the letter T. T and R could mean time and rate. So no, let's make sure it's reading and temperature. And what I'm going to do is I'm going to ask for an integer and say enter temperature. Okay, and we won't bother printing hello, but here we go. Let's run this one. Then I'm going to make some changes to the program to make this a little bit nicer. So temperature reading. Okay, today, earlier today, I measured it was 44. Let's suppose it was 36 the next day. It was 20 the next day. It was 12 the next day. Okay, temperatures don't drop like that here. And 30. But here, you notice that the program is now finished. Let's actually put one extra line in here, print the program is now complete. Okay, but the program ran exactly 5 times. That's a really good thing. Now, of course, it still doesn't solve my problem because it only asks for 5 things. It doesn't decide anything about whether or not it's hot. Well, here's all that I need to do is say, okay, if the temperature is bigger than or equal to, okay, that one's not clear. We'll say 40 or above. Okay, then we're just going to say that was a hot day. All right, here we go. So if we measure the temperature and the temperature is 35, okay, it's fine. If a temperature reading ends up 42, it says, hey, that's a hot day. 45, that's a hot day. 999, yeah, sometimes it feels like that. That's certainly a hot day. And of course, another 23 in here. The program's complete, but it didn't say it's a hot day. Okay, now, obviously a better program would do something a little bit more interesting, but that's at least kind of a beginning. Now, here's the next thing I'd like to do. How about instead of saying enter temperature, what if we said enter temperature reading 1, enter temperature reading 2, enter 3, number 4, number 5, number 6. Okay, notice that there's a pattern. Everything looks the same. Now, we have a counter called reading. And if I were to stick that reading in here, sorry, I don't know how to make that bigger. No, sometimes as I type things, it gets a little wider. I have to figure out how to fix this one. You notice that everything is green. If I use one of those F strings, of course, I want to run this for a second. All right, it says, please enter temperature reading 0. Ooh, okay, strange. 55, of course it's hot. 23, temperature reading 2, 3, 4, and of course it ends. Most people really dislike this because, well, I mean, if you ask somebody to enter a temperature reading, they're not going to turn to you and say, okay, what's temperature reading 0? They're going to say, what's the first one? Okay, pretty reasonable. Now, at this point right here, you have 2 options. Option number 1, you could start reading from number 1 and you could say, well, it's less than or equal to 5. This would be completely fine, you see? So now it does exactly what we want. Okay, it gives me the temperature readings 1, 2, 3, 4, 5. That's one solution. Another solution is to do the following. Instead of displaying reading, you could also just display reading plus 1. So whatever the reading is, just add 1 to it. Okay, here we go. So you go ahead and you read it, and it says, please enter temperature reading number 1. Okay, well, 45. Of course, it's a hot day. This one, 40, hot day. This is 39, 38. And 41 again is a hot day. Okay, perfect. This fixes my output, but it doesn't change my program. Is one better than the other? Okay, that's probably a bit subjective. I would still prefer this one right here, where you start at 0, go less than 5, because that's the way how I set up my loops all the time. And all that I do is when I display to the user, I just add 1. Please note that typing reading plus 1 inside a set of curly braces in an F string doesn't change the reading value, it only displays it. So if I look right here, if I was to print the day number or reading number down here just before I add 1 to it, yeah, I still need to do this. In fact, I often see students will make this mistake and they'll say enter temperature reading number 1. Okay, fine, but enter 1, enter 1, enter 1, enter 1. And of course, no matter how many times you type this, you're never actually incrementing reading. And now what we've got is we've got ourselves an infinite loop. So the only thing you can do is basically stop your program and start the whole thing over again. Okay, so yeah, unfortunately, yeah, this is not an optional thing. You have to actually bring it in. Give me 1 second. Okay, excellent. I believe that that's all the stuff that I'd covered. Okay, so a counted loop. Counted loops always have the same format. There's some code that happens before the loop. There's an initialization where the counter is equal to 0. You basically ask, is the counter less than n? If it is, you do something. The do something really depends on the application, but you increment counter plus 1 and you go back up and you check again. If the counter is no longer less than n, then you do the rest of the code after the loop. Okay, and here's the two examples that we just wrote. Okay, excellent. So that is one approach for dealing with a loop. That is called a counted loop. We know in advance how many things we're going to go. There's a slight variation on this, okay, and that is total readings. We could instead say int input, and we could ask the following, how many readings? Okay, and total readings. All right, so here we go. So first thing up is how many readings? Okay, I've got 6 readings this time. Oh, total reading. Total readings. You have to spell it correctly all the way through. Okay, 6 readings, and of course, well, now I've got the 6 readings, and after 6, then the program finishes. This is still a counted loop because I know for how many iterations we're going to go through the loop in advance. Okay, all right. And again, yeah, you've been through a programming course before. You've definitely seen lots of counted loops. All right, next one up. Okay, over to here, sentinel-based loops or sentinel value loops. All right, so this is a type of loop that keeps going and going and going until something happens, until the user basically says, yeah, I'm finished. So the trigger could be a magic command, or it could be that some condition is turned true. Both of these types of loops, by the way, are used in actual programming. I would say counter loops are used more often, but sentinel loops certainly do exist. Now, the format is a little bit strange because what happens is you end up asking for the first value before the loop, and then you keep asking at the end of each loop. Okay, you know what? I need to modify my previous program. So how much do we want to do? Bang, I'll write the entire thing. Write a program that asks the user to enter temperature readings. Bang, display whether or not the temperature is hot for that day. Temperature is hot. Stop the program when the entered value is -1. Okay, so let me write up the application. Temperature. Okay, here we go. Int input, enter reading. We'll deal with the numbers in a few minutes. While the temperature is not equal to -1, here's what I'm going to do. I'm going to ask the question, if the temperature is bigger than or equal to 40, we'll say that was hot. Bang, bang, here we go. And then, of course, what I need to do is I need to repeat exactly the same question again, but of course, inside the loop. And after the loop, we'll just say rest of program, end of program, whatever it is. Okay, so take a look at this. You see, I can start putting in all kinds of values in here. Hey, that was a hot reading. That's a super hot reading. And a -1 makes everything stop. Because what happens is I end up reading it here. It's -1. And of course, the thing that happens just after line number 12, okay, yeah. Anything that happens just after 12, okay, just after 12. Sorry, I'm reading one thing and I'm trying to do two things at once. Of course, what happens just after line number 12 is line number 9 again. So it's just like having it before. No. Okay, just give me 1 second. Go there. All right, excellent. This is considered a sentinel value loop. Okay, this is very, very useful when you don't know in advance how many things somebody is going to end up typing. And you don't want to ask them how many things. You just want to say, hey, I'm going to go until some condition is met. It's a very, very common programming pattern. The pattern's a little bit weird because you have to get the first reading just before the loop. You have to get the pattern just after the loop. Sometimes people will say, well, how come I need to have it twice? Okay, you know what? It's a reasonable thing. Let me do it. I keep getting the question that pops up. How come we can't just do this? Okay, you see, if you try doing this, well, you can't do anything because temperature has actually not been set. I suppose what you could do is you could say the temperature is equal to 0. Okay, here you go. And of course, now you could get yourself in. That's an option. Okay, that is an option. You initialize it to be something that's false, and that pushes you in. But to be honest, I really kind of prefer having it in this format, an input just before, an input just at the end. The other approach, as I say, it's possible. It's just when you get into real programming, you'll probably find that this will end up just being a little bit more flexible and a little bit more useful. All right, so let's get over to here. All right, so the example, of course, was the one that I just did. And what are we doing for type 440? I'm just keeping myself up to date. Okay, perfect. I'm just a couple minutes behind. All right, that's fine. And here we go. We've got ourselves the example that I just did with the temperature. And I said here, it's okay as long as the Sentinel value is not an expected value that might be entered by the user. Like, for example, is it ever going to be -1 in Qatar? Now, I know some of you who've been here for a long time and have never been in a cold place, you'll say, yeah, I wish it was -1. Yeah, well, okay, I came from a cold place before moving to Qatar. I'm okay if I don't see -1 again. Actually, -1 is not a problem. -40 is a problem, and I don't like that so much. But the problem is that this program would not work in Canada because, well, -1 happens all the time. Okay, so you'd have to use something else in order to stop. And unfortunately, simply putting in something like the word stop isn't going to work because, well, guess what? It crashes because stop is not an integer. And of course, well, this int and int cast, this will cause some problems. There are things, again, that you can do. It's called input validation. You could use input validation to stop your program, but I think we're just kind of outside the scope. All right, so here we go. Back over to here. Okay, and next one. Okay, summation pattern. Okay, this is something we have to do quite frequently. You have a whole bunch of values and you need to add them all together. The thing that immediately comes to mind that I keep boring everybody to death with is if you wanted to calculate the class average of a bunch of tests, you need to start by adding up all of the test scores of the entire class. Okay, well, for the example today, I thought I would do something a little bit different, and that is write a program to add up a bunch of restaurant items to create the total for a bill. All right, so in other words, you go to the restaurant, you buy something that's worth 10, you buy something that's worth 10, you buy something that's worth 20, and of course, well, that should obviously add up to 40, but yeah, you need a calculator to do it. Well, I mean, you shouldn't need a calculator for these numbers, but it does occasionally happen that you will get things that you will want to have something else. So here's what I'm going to do. I'm going to go a little bit further. I'm going to say stop the program when the user types -1, because obviously nothing is going to be -1. Well, unless you got like some kind of a coupon, I suppose. But let's pretend that there's no coupon business. All right, so if I'm going to do something until the user types a magic value, that's called a Sentinel loop. Okay, so here's what we're going to do. We're going to ask for the bill. Bill int input enter bill enter item amount. Okay, I'm changing it a little bit. I'm going to say, well, sorry, it's not a bill anymore. It's an item. Item amount. Okay, well, the item amount does not equal to -1. We're just going to say item amount is equal to, and I'm going to be very lazy here, and I'm going to copy what I put in here. There you go. Okay, first thing up, enter the amount. Okay, 45, 65, 63, 30, 21, 54. Notice the program's going to keep going until I put in a -1, at which point the program ends. Okay, this does not solve my problem. Now what we need to do is we need to actually solve the problem. All right, in order to deal with a total, there's always a usual pattern. The way how it works is you have something called an accumulator. Okay, and the accumulator simply starts off being equal to 0. The accumulator is simply a value that keeps getting bigger and bigger and bigger as you're doing something. So maybe what I would call it is the bill total. So the bill total would start at 0 before you start adding things. Every time that you add something, the bill total would go up by the item amount. And then down here outside the program, you could say that the total bill is, okay, bill total, closing, there we go. There we are. All right, so 10, 10, 20. You always start with something that you know. because it's something you can do in your head. That should be a 40, and if I put in a -1, here we go. The total bill is 40. Okay, excellent. There you go. There's the answer. Now, I suppose what we could do, because it might make the program a little bit more interesting, is let's say enter item. Let's have a item number amount. Okay, yeah, I'd like to have an item number. Okay, watch this. Item number. Sounds like counter loop business to me. Okay, you know what? Maybe it is. Item number is equal to 1. Hey, why not? You see, when I run this, it says item number 1 amount. Okay, 23 item. Oh, I have to do exactly the same thing again. And yeah, these are just string literals, and you can stick in anything that you want with them. So let's repeat this one. Sorry, it's going to go kind of off the edge. But here we go. Kill the old program. Here we go. So 2, 5. Yeah. Okay, this is fine, except of course that item 1, item 1, item 1, item 1 over and over and over again. So let's do it's right here. We'll increment bill, or sorry, item number goes up by 1. Okay, now terminate. Okay, here we go. Run. First one is 23. Item number 2 is 50. Okay, good. Now we're actually starting to get something here that could be of some use. And yeah, if you take the 23, 50, 45, and 95, hopefully that adds up to be 213. Okay, now you see what I've got is I'm starting to put together like what I would call sort of a little bit more of a real application. Okay, excellent. 1, 2, 3, 4. 1, 2, 3, 4, 5. Just give me a second. Okay, maybe a dropout. Okay, here we go. All right, so here we are. So summation pattern. You start with an accumulator variable. Usually they have the word total. Okay, no guarantee of it. It's just that's likely what it is. You start it off as being 0. Every time inside the loop, you increment the total by the amount. You use the total after the end of the loop. Here's basically what I just did a few minutes ago, except this was a bunch of restaurant bills. Okay, I talked about adding up individual items. Okay, it's exactly the same programming pattern, just a slightly different context. All right, so there we go. This is one pattern. Another pattern that shows up quite often is finding the maximum of something. Okay, so let's figure out from the program, we'll make a modification so that not only do we calculate the total, but it also tells me which item was the most expensive. All right, it follows a regular, same, everyday pattern. If you've been through a programming course before, they would have made you do this many, many times. But let's just modify my existing program. So I'm going to keep the old program that adds everything up, okay? And we go until we put a -1, and then we print the total at the end. Okay, I guess we really don't need the end of program. We don't need that anymore. It's pretty clear. But I would also like to know what was the highest amount. The figure of the highest amount, it's always, always, always the same pattern. Before you start the loop, you have a variable called max item. Okay, and what I could do is I could start off the max item. What's the biggest item we've seen so far? Well, when we are on line number 6, before we start the loop, before we ask anything, well, this is the maximum item. Okay, hang on, not here. Okay, good. So somebody has asked the question. This has been recorded. Where do I find it? Okay. There is a link in D2L. There is a link in this chat, but unfortunately, if you join late, you might not see the chat until afterwards. That's the problem with coming in a bit late. All right. I will post those up again a little bit later. Okay, I'll do that once we finish my little modification. Then we'll come at it. Okay, and I will post that up just before we take a break. All right, here we go. So you see the very first item that was typed in, that is the highest amount, the highest item, the maximum item. In fact, I'm going to call it max item. It must be the item amount, okay, because that was the first thing that was put in. But what I'm going to do is right here, I'm going to put this in. Do we do it after? Yeah, you could put this in a lot of different places. I am going to say if the item amount is bigger than the max item, then the max item must be equal to the item amount. All right, so what happens is this gets bigger and bigger, but only if you see something bigger. Now, I'm going to run this. Oh, sorry. I have to say down here, highest item was, okay, max item. Okay, I'm going to walk you through this. All right, max item. When I run this program right now, max item variable actually doesn't exist at all because it only gets set after I type something. If I type a 42, max item is now 42. If I type a 10, well, if I type a 10 here, when I come back around, 10 is not bigger than the max item, so the max item is still 42. If somebody then buys something that's 54, that becomes a new maximum. Now, if we put a couple of small items and then we put a -1 here at the end, you'll see that the highest item was a 54. This is a very, very typical pattern where you set up the maximum item is equal to the very first item. And then inside the loop, you say, okay, if somebody types in a number that's bigger than the max item, then you replace it. Some people will take this if statement and instead of putting it here, they will put it here. That would work completely fine. Okay, that would be fine. I tend to leave it here because I like to have the input as the very last thing before the start of the next loop. Okay, but again, that's just my preference. It would still work. It would just be better if the input happens to be at the very end. All right, back over to here. This is pretty much the case that I put in. I did something a little bit different in this exercise. Okay, so I'm almost finished, and we'll stop again for the 10 minutes. Notice that just after entering the bill amount, I said, okay, this is the max bill amount. I also kept track of the bill number, which is bill number 1. Now, I suppose I could have just said bill number. And whenever I found a new bigger bill amount, I used the bill amount as the max bill amount. And I also recorded the maximum number. And of course, what it is, it would tell me the maximum bill as well as what number it happened to be. So you might be able to say item number 5 was the most expensive at 54, as opposed to the most expensive number or the most expensive item was 54. So it kind of gives one extra piece of information. Okay. All right. And of course, as you see here, sorry, that's the end of the slides. All right. So here we go. Because I know I had a couple of people pop in, so I'm just going to repeat this in the chat. All right. First thing up is I received this piece of information. I'm going into the chat right now about how to reset your password within D2L. In terms of the recordings, just in case, once you do this, then you should be able to log into D2L. So please do try that. And the other thing that I said I would do, sorry, this will take me a few seconds because it's kind of long gone now. Let's see, YouTube Studio. Where's YouTube? View your channel, YouTube Studio. Here we go. Do content, playlists, close, and get your link. Okay, and this link right here, that is a link to the YouTube playlist that I use for this course. So every day I will add another video for the day, and it'll show up in this link. So you only need the one link to the video. You should be able to get, or sorry, to the playlist, which should give you access to everything. Okay, so that out of the way. All right, so what I want you to do, I mean, obviously, if you need to take a break for a couple of minutes, it's no issue. If you can during the break, try to reset your password to get in and see if you can get yourself into D2L. That will at least that way you'll have better access to things because I don't like having to share things through the chat all the time. But what I will do is if you can't get logged in, I will share off the slides again for the day, and hopefully we get it solved by tomorrow. All right, so here we go. Timer, I have to be quiet or I will never stop talking. So timer 10 minutes starting right now. Okay, see you in 10 minutes. Okay, and you're back. All right, so the good news is I'm seeing that some students are able to get logged in, so that means at least the password reset is working mostly. All right, if you see in the chat here, obviously one person had some issues. Hey, it's not my system, but I know sometimes some weird things can happen. Maybe there's a flag somewhere that says I don't know what. You send an email message to the help desk. And okay, good. So thank you make sure to put everything, not just the ID, when you're doing the resets, and hopefully that ends up working. Okay. Otherwise, I mean, yeah, talk to the help desk. They'll be able to work things out. It's one of the difficulties we have, of course, of running online courses. I can't see for sure what people are doing, and hey, these CPE courses are a little bit strange because usually regular courses is like a whole pile of things that happen beforehand. Yeah, we could probably improve the process here a little bit. All right. What I'm going to do, since I know people are getting logged in, D2L is our learning management system that we use here at the University of Doha for Science and Technology. We've been using it for a long time. I think we started this maybe 2013, 2014 as part of CNAQ. I pretty much use it exclusively for absolutely everything. Once you do get logged in, okay, and I know people are in there. Okay, hey, excellent. Thank you for your help. Um, we'll make sure the next time somebody says they're having some issues, we'll have to make sure to include the email at the domain. All right, in any case, once you get set up, basically what you do is you click up here, this little tic-tac-toe type menu, and you will have a list of all your courses. Now, you can imagine I've got a lot of courses because I've been here for a really long time. Chances are you probably have one. It would be CPIT 1020. Okay, and I'll show you the things that we'll be using in here. So let me view this as a student so it looks a little bit more like you guys. All right, first one up is the area here called news. I will always post things that's going on. Like if something happens and I'm going to be like 10 minutes late or whatever, I will definitely post something here to say, hey, sorry, just wait a few extra minutes or whatever. Hopefully it doesn't happen. But in any case, we've got the link to the Zoom, which obviously you guys have already. And a little bit further down here, we have access to the Python interpreter. That's the one that I'm using. And now what this means, I can go back and put in my restriction again, but I'll do that tomorrow. All right, so there you go. That's everything. The thing that's going to be of a lot of that's course home. The thing that's going to be a lot of interest to you for this course is simply the content. If this was another regular course, there's lots of stuff for Dropbox for assignments and quizzes and so on. I don't know if we'll be using that. Maybe the final exam will show up here, but generally you're probably going to end up being interested in the content. And you can see what I've got here is I've got the lectures 1 through 6 at the moment. Okay, so hey, we're about to do loop 4 loops, lecture number 5. And of course, right down here is the Zoom recordings, this is the YouTube playlist for everything. So that YouTube list will just get longer. And that way I don't need to keep updating it. I can just say, yeah, go to the playlist and everything is there. All right, so, and table of contents just looks exactly the same, except you see more stuff. All right, so there you go. So excellent. This is where I will put the information next class. For example, somebody was asking about additional exercises, okay? And of course, you'll see this right now, but I don't have anything here yet, okay? It's pretty simple. I drag and drop the stuff here, okay? But I will do that after this class. Okay, let's get this out of the way. There's a lot of excitement going on out here. We have a lot of uh, facilities workers doing a lot of work, making a lot of noise. I suppose they thought that nobody was here, and they didn't know that I wasn't here. Okay, or that I was here. Okay, let's clear this. Let's clear this, and let's get into our slides. All right, and let's get started. Okay, this is lecture number 5. It's called Loop Modifiers and For Loops. Okay, excellent. Again, for those people coming from, I'm going to say some languages because it's not entirely true. You're going to see some of these loop modifiers. The for loops, of course, everybody will see. Okay, so let's deal with the loop modifiers first. All right, here we go. Okay, kind of a strange thing. I start off with infinite loops. Well, an infinite loop is a loop that never actually finishes. It just keeps going and going and going and going. Okay, that's fine. And of course, well, we're probably told never to use them, but to be honest, I actually use them quite a bit. I use them for different things. Infinite loops actually do have a purpose. Like, for example, my copy of Zoom is running right now, and it's probably stuck in something that looks pretty much like an infinite loop. Eventually, once I quit the program, well, then everything's going to stop, but it probably actually looks very much like this right here, while true. Okay. But you can't just have a while true because you need some way of getting out, and that's where this thing called break comes from. Quite often, I will write up code using one of two options called break and continue. And here's what I'm going to do. I am going to write up a little application and okay, there you go. While true, print hello. Well, what happens here is, of course, we find out whether or not true is true, which it is, and I go in and I print the message. I come back up here, and because true is still true, it prints the message again, and it prints the message again. The result is I get basically an infinite output. By the way, if you're going to be using my little online interpreter here, don't let infinite loops run for a really long time because it'll burn up all the menu and it will cause your browser to crash. Okay, so infinite loops on their own, maybe not so useful, but there are things that we can do. Okay, for example, here's what I'm going to do. Command. Oh, by the way, I don't know if people have ever used a command prompt before. We're talking about CMD from the world of DOS or Windows or a terminal in the case of a Mac or a Linux machine and so on. And of course, what's it doing? Well, it keeps asking me, waiting for me to type things like pwd, waiting for me to type commands like cd. I can run copy commands if you're coming from Windows, until, of course, I type the magic word exit. Bang, at which point now my application is finished. How long do we do this? Well, we just keep on going and going and going. So the command would be something like this. Okay, here we go. Prompt, bang, here we go. All right, here's what I'm going to do. If the command is exactly equal to exit, then what I'm going to do is I'm going to call this weird looking little comment called break. Otherwise, I'm going to say processing command. Okay, so here's the prompt. You type a CD. I'm going to process CD. I type a copy. It's going to process a copy. I'm going to process an RM for removing something. No problem. I'm going to process that. Sure, that's what I'm going to process. If I type the word exit, you'll notice now that my program is now finished. This is a way to get out of a loop. It doesn't have to be just an infinite loop. It will actually leave any other loop that you ever possibly want. Okay, and that's it. Okay, so this is one way of stopping a loop. So you're in the middle of it, everything after the word break is left out, and the entire loop is then stopped. Now, there's another word that goes along with this, which is pretty similar. It's called continue. All right, and here's what happens with a continue. When you use a continue, what it does is it stops the rest of the loop, but it goes back up and it checks the loop condition again. So this one will be a little bit different. For example, if I type TTT, it says it's processing TTT. If I say LS, it's processing LS. If I type exit, notice that it didn't say processing. That's because it skipped over this, because the continue says go back up to the top of the loop and keep going. Now, unfortunately, what I've just done is I've created an infinite loop that I can't get out of, because typing exit, I'm not actually finishing. So I'll have to click on it, terminate. That doesn't mean that you couldn't have just a continue, but if you want a way out, you need a break, or you need a condition that ends up eventually becoming false. Okay, why do they have this? Now, I think way back to my first introduction to programming courses, we had kind of similar things to this. We had an option called a go-to. If you took programming courses way back in, I'm going to say, okay, maybe 15 years ago, people would have been using go-tos and it was like, no, 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 bad, 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 bad. And this unfortunately kind of fits that category, as it's generally people really don't like it. Okay, but it's a way to get out of a loop sort of early, either to stop it altogether or to go back up and do something else. Some people will say, no, 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 we should never use them. Other people say, yeah, it's completely fine. You see, this is kind of a way to have a Sentinel-based loop without having two inputs. Okay, and yeah, and to be honest, I use them occasionally. Here, I popped one open earlier. That's something different. That's for an example later. Okay, I was in here looking to see whether or not I used any breaks or continues, and I didn't use anything here in course scripts. Sorry, let me open up another one. Maybe D2L processing. Sure, another window. Perfect. Excellent. Sorry, I can't make the font any bigger, so sorry if you're on a small screen. It's a little bit small, but notice the word right there? Yeah, I use it. Okay. It doesn't have to be a for loop. We'll talk about these types of loops later, but yes, I use it. And basically what I said is I'm trying to get rid of unwanted quizzes because some instructors are calling quizzes practice and revision and pre-lab and lab support. And this particular script is looking for a certain case called flapping. And what we've got here is if it happens to be practice or revision or pre-lab or lab report, then what I do is I say, you know what? Don't do this operation here. Just go back up to the top of the loop and keep going. It is actually really, really useful. You don't need them. It's just really, really useful. Okay, in any case, I had to include them because, sorry, I had to get back to, that's not the one. There we go. All right, so basically, if it makes your loops difficult to read, then you avoid it, and if it makes your loops easier to read, then you use them. That's the way how I use them. There are certain types of loops where they're very, very useful, some cases that are not. I don't know how often you're going to see me use it in the course, but hey, I'll give it a try. All right, but in any case, break and continue. It works for all the types of loops. It doesn't matter if sentinel value or counted loops or anything else. Just remember that a continue goes back to the start of the loop. It keeps going inside the loop, and a break stops the entire loop, even if it's inside an if statement. If it's inside another loop, then no, it doesn't work that way because it'll break the loop that you're in, not the outer loop. All right, so there's an example in right here. I guess this is pretty close to what I just did. I've got an infinite loop where somebody is asking for a direction. So maybe it's like a game. I said some robot, maybe you're moving a robot around. If the direction is equal to quit, you use the break to get it out. If the direction is not in up, down, left, or right. Okay, this thing right here, by the way, is called a set. We will see that maybe tomorrow's class, I think. If it's not one of those things, then you print out the word invalid, but you continue. You don't stop the program, you continue the program. You go back up to the top of the loop and you ask for the next direction. And then finally, if you make it through the past this if statement and this if statement, then you can say that the user picked this and then you can actually process it. Okay, and then when the program stopped, it said, thanks for playing. I guess it was thanks for using the robot. I changed my mind halfway through what we were doing. All right, in any case, here's an example. It's pretty close to what I just did, so I don't think I need to repeat. All right, this one right here. I was trying to find some stats when I was putting together the set of slides. Comes from an INFS 1201 slide, and the biggest well-known program or website that uses Python that I could find is Instagram. So yeah, actually the back end of Instagram uses Python apparently as its back-end engine, and it's about 100,000 lines of code. So pretty big thing. And there was a question that popped up and it said, how many loops do you think there are? Now, according to some estimates that I've found, okay, and yeah, actually, I think I may even asked ChatGPT to kind of confirm it. Well, again, it also just pulls stuff from the internet for me, which happened to match what I found. It said that there was about 1,000 loops. Okay, so in 100,000 lines of code, there's about 1,000 loops, and the estimate was between 60 and 80 of them would have been counted loops. Yeah, almost everything in programming is a counted loop, more so than Sentinel-based loops. It doesn't mean the Sentinel loops don't exist, but most of the time they're counted loops. A for loop is a convenient way to write a counted loop. All right, so for this, I am going to go back to Java for a minute. Okay, so for people from Java, okay, yes, you would certainly have for loops. You would see something like this. For int I is equal to 0, while I is less than 10, I plus plus, and you'd have a set of curly braces, and you would do something. Do stuff. All right, and of course, there's nothing special about a for loop. That's really just a while loop where the increment and the initialization and a condition show up inside the parentheses on the for line. That's it. There's nothing special about these for loops. Python, and of course, it's a convenience. This is all that it is. It's convenience, is to make the programs a little bit easier to write, a little bit easier to read. And here's what we're going to do. I'm going to write a small counted loop. Remember the program that I wrote at the beginning of last lecture, like an hour ago? I wrote up a loop something like this. I would have said counter is equal to 0. I said, well, counter is less than 5. Print hello. And then I said counter goes up by 1. And then I'll just say that the program is done. When you run it, of course, what happens is you get the hello gets printed 5 times. The counter goes up each time, and then I print the done at the end. If I wanted to, I could even include the counter as part of the output, and you'll see that it goes 0, 1, 2, 3, 4, and then of course it stops. All right, counted loops show up all the time. One of the downsides or one of the dangers of a counted loop is you might forget to increment the counter, and then of course now you've got an infinite loop. It's one of the things that you get from a for loop is you tend to remember to increment, because if you forget the I++, you do remember it, okay, because you usually don't leave it for long. In the world of Python, there certainly are counted loops or for loops that help you to write counted loops faster. Okay, here we go. For counter in range 5, print hello. Now, I know the syntax is a little bit strange, okay? So first of all, we've got a couple of extra things. We know it's a for loop, okay, that's fine, but now it says counter in range 5. What the heck is that? Okay, well, let me run this first. It doesn't do anything unusual, okay? Well, hopefully you guess what it does. It goes through and it prints out the word hello world exactly 5 times, okay? So, okay, it's kind of sensible. But what about this thing called counter? Well, you know what? It works exactly the same as what I just did a second ago. Okay, here it is. Hello, 0, 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4 for a total of 5 things. It's just a convenient way to write a counted loop. Okay, notice that I don't have to remember to say counter goes up by 1. I don't have to initialize counter to be equal to 0. Instead, all of this is looked after by this thing called range. Okay, it's just a convenience. Okay, if you don't get extra power, it's just a convenience. Eventually, we're going to get things that are much more powerful with for loops, but not at the moment. When you start to deal with advanced data structures like sets and queues and lists, it's really, really handy. Still, is it extra power? Yeah, maybe in one of those cases. However, this is, for right now, it really is just a convenience. If you can avoid an initialization and an increment each time, hey, that can improve your speed of programming because it's less lines to write, it's less problems because, well, the less code you write, the less problems you've got. All right, so when you use a for loop. So you can use a for loop when you know how many times in advance, how many times or how many options or how many times you have to repeat something. You can also use it for iterating over characters in a string, which we will see in a little bit. Oh, this all seems very repetitive. And you can also iterate over complex data structures. That I'm going to cover. This will be maybe tomorrow's lecture. All right, so basic for loop structure. The range function basically gives values from 0 to n minus 1. Hey, now very interesting, 0 to n minus 1. Let me remind you where we've seen this before. The variable inside here, this for I, that's called loop variable. Over here, it's called counter. Okay, fine. 5. Now, I'm going to include something else, 2 comma 5. Okay, if I provide 2 numbers, the output changes up a little bit. Take a look what happens. It runs with a value of counters equal to 2, 3, and 4. And you say, hey, what's going on? Let me remind you of the following. Okay, here we go. Temp is equal to 0, 1, 2, 3, 4, 5. And if I said, oh, you know what? Let me say this instead. QWERTY. Okay, QWERTY. If I said temp from 2:5, what would I end up getting? Well, I would get the letter E, R, but I wouldn't get the T. 0, 1, 2, 3, 4. I would get the T, but I wouldn't get the Y. Okay, there you go. Where's the run? Okay, so I get the ERT. Okay, excellent. So it works exactly the same way. You start at position number 2, you go up 2, but not including position number 5. All right, yeah, we can do something else kind of weird. Let's go up to the number 40. Okay, let's get rid of this one. Here you go. So 2, 4, 6, 8, or sorry, 2, 3, 4, 5, blah, 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 blah. And guess what happens if you put a 2 here at the end? It works exactly the same way as the slicing. What it will do is it will increment by 2 each time. So we'll get 2, 4, 6, 8, 10, 12, blah, blah, blah. If I were to put in something like by 9, it will go up by 9 each time. Okay, so it's actually kind of a very, very convenient operation. And it's kind of similar to list slicing. The range function is actually a function. What it returns a range. So it's kind of weird. This is the only place where you can use it is in a for loop. I've never found any way of using it outside of for loop. I suppose that there is. And the values work exactly the same as what you want, but I'll be honest, most of the time you leave it like this. You don't worry about the starting and ending conditions. You just want something to repeat 40 times. There you go. It's 40 times. It starts at 0, goes to 1 less than 40. Okay. And if you need the values from 1 to 40, fine. Just like what I did earlier, add 1 to the counter each time, and you get the numbers from 1 to 40. Okay, so pretty straightforward, more of a convenience than an absolute necessity, but nevertheless, as I say, this is kind of a useful thing. Okay, so there you go. There's the range function. Now, there's one kind of really clever thing that we can do. 42. Whoa. Okay, hey, you know what? Sometimes this happens. I think I'm actually going to be on time this time. Actually, I'm going to be a couple minutes early. That's really shocking. What I will probably have to do is I'll have to go back and repeat an application. Okay, but that's fine. I think we've got an application about asking for temperatures. Excellent. We will do that using a for loop. All right, so we'll repeat it using a while loop, then we'll turn it over to a for loop. All right, here we go. The next one up, strings. Okay, strings can also be used with for loops, and this is very, very convenient. Okay, there you go. This is course name CPIT 1020 Intro to Python. Let me do a couple of things. POS is equal to 0. And sorry. Print course name 0. Okay, hopefully you remember what this is. This will print the very first character. This will print the next character. This would print the next character after CPIT. This one right here, give me a T. Rather than doing this, what I could do is I could have, say, a for loop to say POS is in range 5. I could say print course name at POS. All right, now take a look what this does. What I do is I iterate through the first 5 characters. I iterate through the values 0, 3, 0, 1, 2, 3, 4. And what I'm doing is I'm pulling off the individual item at that position. And I'm printing out CPIT and a 1 because I asked for 5 things. I suppose I should have asked for 4. It may have been a little bit more interesting, but there you go. There's CPIT. All right, so that's fine. That's using a for loop. That's one way to use a for loop to go through each of the characters of the string. But because this happens all the time, this is actually how for loops are used with these things. When you write up a for loop here, I'm just going to use a magical letter X and I'll replace this in a couple of seconds. What it does is it will go through each of the letters inside the string one at a time. So it's a really cool way to go through and look for something. Okay, that's or to look for, I guess you could be looking for something. All right, so for example, right here, it goes through and it checks each time. All right, well, I'm going to ask you a very simple question, and this one isn't here. How many spaces do I have in this word or in this string? I've got 1, 2, 3. I've got 3. Now, of course, if this is much longer, maybe you want something different. But here we go. Let's count up the number of spaces. So I'll call it spaces is equal to 0. Okay, here's what I'm going to do. Instead of printing it, I'm just going to say if X is equal to a space, which of course is spelled with a space, you put it inside a quotation mark, then I'm going to say that spaces goes up by 1. And at the very end of my program, I could say there were spaces spaces in the string. There you go. So take a look at that. There were 3 spaces in the string. Pretty cool. If I put an extra one in here, bang, there you go. Now there's 4. So it's a very convenient way to iterate through individual characters of a string. I wouldn't call it X. I would probably call it CH to remind myself it's a character. Okay? Or perhaps that it's a letter. Now, I had an exercise here the other day. Okay, now give me a second because not over here, over here. I want to spoil it for you. At the very end of last class, oh, I made it difficult for myself. Here you go. At the very end of last class, I gave out a string that looked like this. It's an encrypted message, and what it is, it's got a whole bunch of numbers in the middle of it. All right, and here's the thing. You see, if I print the sentence right now, this would show everything. But what I wanted to do is to take the sentence and I wanted to make it equal to the sentence dot replace. And I was going to go through and I was going to replace, say, the one with nothing. And then if I print the sentence again, you'll see what happens is it's now repeated, but there's no more ones. And then, of course, well, I did this yesterday. I said, hey, we can do it for 2, then 3, then 4, then 5. Okay, 2, then 3, then 4. Okay, yeah, we're getting a little bit closer. If I just do it for 5, then 6, then 7, then 8, then 9, excellent. But remember what I said at the beginning of today's work. I said, if you copy and paste something more than once, you're probably are not as efficient as you should be. And this certainly looks repetitive. Okay, well, how can we take this to our advantage? Well, here's what I'm going to do. I'm going to have a variable called digits. What are the digits? Well, digits are 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hopefully that's all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I'm going to do is I'm going to go for a dig in digits, because I know that's a pile of digits. And instead of replacing 1, I'm going to replace dig with nothing. So you see what I'm going to do is I'm going to replace the 0 with nothing, then a 1 with nothing, then a 2 with nothing, then a 3 with nothing. And the really cool thing is when you're finished, yeah, it gets rid of all of these. So there we go. This is the type of thing that makes programming sort of more manageable. Copying and pasting a pile of times is really not a very good idea. But here, now we're able to use a loop and we just happen to recognize that, hey, this is a pattern. Okay, there's a few different ways how we could do it, but because we just had iteration of characters over a string, I thought, okay, this is perfect. This is exactly what we need. All right, so there you go. There's a way how we can get rid of all those different digits. If I want to get rid of other things like explanation marks and all of these because my screen was or my message was filled with them, there you go. Okay, you see, this didn't end up working as well. Okay, apparently I've got a Q in here. Okay, somebody typed a letter Q by accident. I think it was me. I guess I can't blame you. You weren't here. There we go. So you see, it can even get rid of these extra special characters. So this can be kind of really clever. Okay, and this is all done by having a string and then iterating through each of the characters of the string. Okay, now what on earth do I have for this next thing? 32. Well, I'm going to be finished way too soon. Oh, what am I going to do? Well, that seems incredibly weird. I'm definitely not going to stop and take a half-hour break. That'd be ridiculous. If we were going to take a half-hour break because I've finished everything, I'd rather take it at the end than right now. All right, well, let's go through and see what we've got, and then what we'll do. Oh, this will work out well, I think. All right, the final slide that I left in this slideshow today was when do you use a while loop? When do you use a for loop? And dig. Oh, okay. Sure, I don't mind that. Okay, somebody's asking to elaborate on dig. All right, remember what this is. Let's not do this, okay? Print, dig, and please let me clean up my stuff so I just have the digits because now I don't have digits. And I don't have all those things. I'm trying to put it back to what I had. All right, so take a look what I've got here. So remember what this is. This means dig is digit. That's it's not an acronym, it's an abbreviation. I should, I suppose, have called it digit. Okay, because if I were to print out those digits, those are the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so sorry about that. I should have actually wrote digit rather than dig. Okay. Yeah. Sometimes in programming, you get lazy. Okay. And this is me being lazy. So thank you for calling on it. All right. So dig is digit. So really what I should have been doing is I should have been replacing, if I can ever figure out what's here. There we go. I could replace the digit with a blank. There you go. And that's the cleanup version. Okay, sorry about that. You see, I could say the following. You see what happens if you use cryptic names for variables? People don't know what you're talking about. Ooh. So I fell victim to my own stuff. All right, so is it okay? Because, all right, here's what would happen. Here's what I'm gonna hate to call it. I bet a programmer would probably do this. Is D an okay variable for a digit? Okay. Now, there's two answers to this. One camp will say, no, 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 you can't use single letters. Okay, that's reasonable. Don't use single letters for variable names. Use something a little bit better. But I'm going to be quite honest with you, and I'm going to tell you that a lot of people would probably use D in this loop. Why? Okay, how big is the loop? Well, the loop's not very big and it's coming from digits, so it's pretty reasonable to say, that's what it is. What I wouldn't like is the letter S, because now that doesn't make any sense for S in digits. That's not entirely clear. This is about one of the only places where I don't mind single letter variables. Okay, so based on that, let's go look at some of my loops. Uh-oh, am I responsible for this? All right, take a look at this. For events and data, okay, that's pretty reasonable. For flapping and filtered, okay, that's pretty reasonable. Let me see. If row is while true. Hey, look at this. I got myself an infinite loop with a break. Hey, it does happen. Um, I understand the S like for this exact part. Okay. All right. I'll go back and I'll cover that in a second. All right. So let me finish this one. Let me see how bad I have been. Okay. Daily diff objects. Okay. Hey, I'm not using too many single letter things, even my own real code, but I'll be honest, I do use them occasionally. Okay, so yeah, it does happen. All right, so somebody is still not sure about the S. Okay, so let's get back over to here. I hope that it isn't I hope that it's not the S that's messing you up, but it's sort of the misunderstanding about the for loop. Okay, but in any case, we'll do this. All right, here's my name. I've got it stored inside a variable called name. And when you use a for loop and you say for some variable name, doesn't matter what letters you use, doesn't matter what it's called, in a string, what will happen is it will iterate on terminated literal. So yeah, here we go. It's for the for loop. Here you go. Okay, what it will do is it will go through each of the letters inside the string and it will do one iteration. So in this case, all that I'm doing is I'm simply printing it. That's why you see my name showing up vertically because I'm going saying, okay, go for each name. So for the first letter, pull out the R, print it. Next one, print the O, print the B, print the E, print the R, print the T, print the space. Yeah, it doesn't show like anything. Then the F, the O, or the R, and the D. In terms of actual variables, as what I've been saying, it doesn't matter what the variable is called. Okay, still works exactly the same way. All right, but when you have a string, when you have for a variable in a string, what you're doing is you're setting up, and that's exactly it. You're pulling out the individual characters. Okay, now you have to be very careful about this because watch this. So when we had this before, yeah, okay. But well, S doesn't stand for anything. It's just a variable. You remember, variables can be whatever you want. Okay, remember, this is just a variable. You get to make it up. And yes, this would end up working. I don't think anybody would ever do this, but this program would also work exactly the same. Okay, it's just a name. It's a name that you pick. Now, what would I describe each of these? I might describe it as a letter, I might describe it as a character. I might be a little bit lazy and I might just call it CH. I suppose I might even call it C. I don't like that one so much, but maybe what I would use is CH. That's usually what I use for characters. But if you like car, again, it's whatever you want to call it. Okay. And hey, if you really, no, there's no, no, it's not a special thing. It's just a variable. Okay. So it's the word for has to be here. This right here, that's your name. Okay, it's whatever variable you want. So it's not any kind of special word, it's whatever you want. Okay. All right. So if that was a confusion, excellent. Hopefully we've got that one. Okay. All right. Somebody didn't want us to have a big break. No, it's okay. It's okay. I was actually quite surprised I finished so quick. Okay, so let's go off to the final one. Here we go. All right, so when you pick a while, when you pick a for, well, basically you can use a while loop all the time. The time that I use a for is if I have a range and I'm looking for numbers between 0 and a certain value, or if I'm iterating over a string, or if I'm iterating over a list of values or something else. But those are advanced data structures. Really, a while loop can be used for all of the cases, but for convenience, you'll find for loops are sometimes helpful. Okay. All right. There we go. All right. Well, I have 10 minutes, and rather than do nothing for 20 minutes or even taking a break now, I would like to start for at least a couple of seconds in the final slideshow. Okay. And that way, at least we can definitely stop. We definitely finish on time. All right. Okay, here we go. This is the next one. Okay, and if we finish everything early, excellent. And I don't mind having some questions. We can make up some exercises. We can say, okay, fine, we're done a few minutes early. It's we can have our flexibility at that point. But I have a feeling that functions may take a little bit more time. All right, perfect. 10 minutes. I've got a really good thing here to get started with. All right. A function, okay. Again, everybody has obviously, as everybody said, that they had been doing some programming at least at one point. Maybe it was even just in a course. You definitely covered functions in your course, at least I'm assuming. And the thing is that functions are really the building blocks of absolutely everything. I often get students say, "Oh, we don't like these things called functions," but I would say that if functions don't exist, um, you can say goodbye to every program that you ever used because you really need to have functions. It's the way how you deal with really large programs. I've talked about before, I've worked on systems that are about 100,000 lines of code. Trust me, it wasn't all just one big long program because that's way too much. What you do in those types of programs is you divide things up into small building blocks. You see, it's the same thing like if you're trying to build a car, you don't just try to build everything at once. Yeah, you get a transmission which needs to go together. You have an engine that needs to go together. You have wheels and so on. All of these things go together, and eventually you put everything together to form the car, but you don't start tacking on individual parts one at a time. All right, that's basically the purpose of a function. Okay, so let's consider a real life problem and then we'll have a real life solution. All right, so imagine this. You're running a coffee shop and you need to provide the following instructions because whenever somebody comes in to do something, the customer doesn't come in and say, steam the milk, brew the espresso, combine and serve. No, instead, the customer comes in and says, make me a latte. You see, this is a more abstract description about what somebody wants, but these are the actual details about what needs to happen. Okay, so instead of this, the real instruction is make a latte. And that's exactly what the function is. You define what it means to do something, and then later you simply use the name of the operation to make it happen. And we're going to be doing a bunch of these things. Okay, in fact, all my examples down here on the side comes from this example of brewing up the latte. Okay, and in 7 minutes, if you want to go make one, okay, excellent. Then go out and do it. You can brew yourself some espresso to stay awake for the final 1 hour. And if you want, you can turn it into a latte because we'll actually have some instructions. Okay, why use functions? Okay, as I said, it breaks large programs into really small ones. Okay, you know what? I've got a program sitting here right now. This is PowerPoint. All right. You think about PowerPoint. This is a pretty complex piece of software. I bet this is somewhere around 200 to 300,000 lines of code. Probably not Python. Likely it's C++ plus plus, as if I had to take a guess, just because Microsoft, I think, did a lot of their stuff in C++. plus plus. So I'm assuming that it is a C++ plus plus application. 100, 200,000 lines of code. How do anybody keep anything straight? Okay, well, here's the secret. You see, every place that I can click on, that's actually a function. Like, for example, if I click over here and I bring up this menu and I say, give me a new slide, well, guess what? That is a function. There's probably a function called new slide. Oh, what did I just do right here? Well, what I did was I clicked on delete slide. I used a shortcut, but right here, delete slide, guess what? That is likely a function. In fact, everything that you see here, duplicate the slide, add the section, format the background, hide the slide, link to the slide, zoom, every one of these things is likely a function. It's something very, very specific that solves one particular small piece of problem. Okay. And all that this is, it's an instruction that we can reuse over and over again in different contexts. Like, for example, I can duplicate this slide right here, which obviously duplicates my real life problem slide. And exactly the same code could end up happening down here for function returns. Okay. It's the same code, it's the same operation, but different page. Okay. Different set of slides, or sorry, a different slide. That's, as I said right here, this is probably the most important reason. It breaks up larger problems into smaller problems. In the world of programming, we call it problem decomposition. Okay, we use this all the time. When you're working on a working on a big piece of software, you take a big problem and you break it up into a whole bunch of little tiny things. It avoids you copying and pasting lots of code. Oh, wait a minute. So did loops. Yes, yes. That doesn't mean that loops and functions are interchangeable. It just means that they both can be used to avoid copying and pasting code. It also makes programs easier to read and to maintain. Okay, it really does. Although, unfortunately, a lot of students look at it and go, oh, I don't like it because they're difficult. Okay, well, actually, they're not that difficult, but they are really, really, really critical. But there's a couple of tricky things. And if you don't understand the trickiness, you're going to find yourself with a lot of trouble wondering, why am I doing this? Now, I'm going to include just this one slide right here. Then we're going to take a break for our 10 minutes. I think this will be the right thing. All right. And you can see that there are types of functions. There are functions called built-in functions called print, length, and int. Okay. Ooh, name. Here's my name back again. Okay, print. Okay. Let me zoom in a little bit just so it makes it very, very clear. If you notice, the word print is in a weird color. It's a purplish color. And what this is a built-in function. So yes, there is a function called print. What does it do? It prints something to the screen. Excellent. All right, there's a function called input. Yes, exactly the same. That's built in. There's another one called len. We saw this one yesterday. What it does, it goes through and it counts up the number of items in a string. Excellent. There's also one called max. Okay, when I run this program, take a look what happened. It print the biggest number. Oh, and by the way, it doesn't matter exactly where the number is. If I try running this now, yeah, it prints it up this one. So yeah, there's something that can be used for printing the biggest number. Ooh, we were talking about finding maxes earlier. Yeah, unfortunately, it's not useful unless you have something called list. Lists? That'll be next class. Okay, excuse me. The maintenance guys are getting closer. It's getting noisier. All right, so my next one is probably going to be really bad. All right, each of these purple things is a built-in function. Okay, it comes part of Python. You can just go ahead and use them. You don't need to include anything. Hey, for those who are familiar with Java, system.out.println. You can just use system.out.println. You don't need to bring anything in. Whoops, for those who are dealing with C and C++, if you try to do this, all right, this will fail compiling. I can't even demonstrate because you forgot to include stdio or whatever you got to bring in now. Sorry, I can't remember exactly what I have to bring in any longer because they were changing things around. All right, but in case you don't get any functions built in for free, but in Python, functions like min, max, print, input, length, type, all of these things are built in. You also have a bunch of module functions. For example, if you needed to calculate, say, the hypotenuse of a triangle. Okay, I know you'll look at that and go, what? Yeah, yeah, it's one of those math concepts. But what you need to calculate this is, here we go, hypotenuse of a triangle. Here you go, triangle formula. Okay, excellent. And if I pop open MathMonks, okay, this will be good. Here we go. So how do you calculate the length of this one right here? Well, there is a formula and it says that it's a squared plus b squared, and then of course the square root. Well, how on earth do you calculate a square root? Well, the good news is you don't need to know how to calculate a square root on the computer, but in Python, you can bring in the math library. Okay, so if you need to calculate the square root of something, you can just say math.sqrt and 25. And hopefully you know that the square root of 25 is the number 5. 5.0 to be exact. Yes, this returns floats, just what we talked about last time. So that's how you calculate. So there's a whole bunch of functions that are not built in, but you bring in from various modules. Okay, so yeah, this is probably the most popular one, but we've got lots of other things, depending what you're looking for. For example, if you want random numbers, there's a module for that. The final thing is user-defined functions. What does it mean for your application? You see, making a latte is not a function. You try running this, it says, ooh, make latte is not defined. Yeah, and unfortunately, you can't import coffee and say coffee.make latte. It doesn't exist because it's not built in. But that doesn't mean that it couldn't exist. It just means that it doesn't exist right now. But what we can do is we can make our own function called make latte. So whenever we want to make a latte, we just have to say make latte rather than actually doing the exercise ourselves. All right, perfect. This brings us up to 5:50, which of course is is a very good time that we can now take a break. So here we go. 10-minute break starting right now. Book. There we go. So I will now be quiet. In fact, I think since I'm here, we'll drag over a YouTube timer. I forgot about these things. YouTube, and we'll say 10-minute timer. Okay, excellent. There you go. There's your 10-minute timer. Okay, see you when this reaches 0. Make a latte right now if you want to. I'm going to make some tea. Okay, here we go. Yeah, I know that's just about to finish, but we're actually finished. I don't know if it makes a sound or anything that happens afterwards. Maybe it just goes away. All right, in any case, here we go. It goes away for right now. Bang, gone. And out of this, back to here, and back out a little bit. All right. During the break, I uploaded a copy of a file called lab.zip. Download this, extract it, and you will find labs from my INFS 1201 course. Ooh, a second, here we go, labs, and I can show you just one. So like if we grab this one right here, this is exercise 3 loops. Okay, perfect. There are 2 documents. One is a set of questions. Okay, hey, and take a look what you got. Adding things up and you're counting how many things we've got. Sorry, some of the exercises in here are really weird, by the way. I didn't make them up. I've been slowly trying to fix them and make some of the weird ones a little less weird. Most of these should also have a solution. So if you wanted to see the answer, you'll find it sort of wrapped up in these little boxes. Okay. As usual, I mean, my recommendation is don't start by just looking at the solution. Actually, you want to try them first. And if you don't understand what's going on or you can't figure out how to solve it, fine, then take a look. Let's see, week number 4. Okay, exercise set 3. You can certainly manage. Okay, you see, exercise set number 4 functions. You see, we're pretty much on track. But what's going to happen is 5, 6, 7, 8, 9, blah, blah, blah. We're going to finish all of these by the end, or you will be able to finish all of these by the end of this week. Okay, by Wednesday night, you should be able to do all of these things. And as I said, these are here. These are for you to work on. You get stuck on things, by all means, send me an email between now and the day of the exam, and I will do my best to be able to answer. Just make sure to include that you're coming from CPIT 2010 so that I know who you are, so I'll answer it. Because if I get questions from other students during my summer, I usually don't. Okay, let's get back over to my slides. No, no, no. Go away, go away. Here we go. Now, sorry, I got to find where my slides are. Okay, I never had a show running. So now we can make it run. Okay, excellent. This is where you left off. So remember, a function is simply something that we can use in order to make our lives a little bit easier. And here's what we're going to do is now let's make our lives a little bit easier. I'm going to start with some very, very simple things, and that is I'm going to define a function right here. And sorry, I'm not going to type all of this. The workers here are really, really loud today. Remember what we were trying to do? We were trying to make a latte, but unfortunately, we have absolutely no idea how to make a latte because this is a very, very abstract thing. But what we can do is we can tell Python how to make a latte. Oh, that was not helpful at all. Really? I can't copy and paste that stuff? Oh, no. Oh, no, this is going to take me a couple of minutes. Sorry about this. This was not as I expected. I copied and pasted. I thought everything was going to be fine. Oh, sorry. It, it, okay, the good news is I think I can, now I see why I don't copy and paste stuff very often. And by the way, I know everybody likes to copy and paste stuff because my students always do it. My recommendation in life, especially if you're doing anything to do with IT or programming, learn how to type. You need the practice, by the way. All right, but here we go. What I have done right here is I have defined what it means to make a latte. Okay, so what this is defining the function make latte, and this is actually calling the function to make a latte. And you can see what happens now when I run my program. The make latte actually understands what it is. Now, if I remove the call, absolutely nothing happens because I haven't actually said, go and make a latte. All that I've done is I've said, this is what it means to make a latte. Okay, so in other words, yeah, this is the recipe about how to do it. I mean, somebody's gone and they've said exactly how many grams and milliliters and so on to put in, and of course they've even included enjoy your latte. And of course, well, what if 2 people come in one after another? One person says make a latte, another person says make another latte. Well, you know what's going to happen is the same set of instructions is going to happen twice. So take a look. You see now when I run this application, you'll see step 1, 2, 3, 4, 5, enjoy your latte. But then you'll see steps 1, 2, 3, 4, 5, enjoy your latte, exactly the same things again. So it isn't replacing the statements here down here. What you're doing is you're making a call where you jump up and you actually execute each of these statements one after the other. And when you finish, you go back to where you came from. It's called a return, and then you go through and you can do another one. Like for example, hey, what about if I did this? For counter in range 10, make latte. Well, what's it going to do? It's going to make 10 of them. Yeah, it's going to repeat the same instructions 10 times. It's going to call this 10 times. Now, to make it a little bit easier to see, maybe what I'll do is I'll put like some separators. All right, so enjoy your latte. Boom. So there's 1, there's 2, there's number 3, there's number 4, number 5, number 6, number 7, number 8, number 9, and number 10. There you go. So yeah, it's repeated 10 times. This is a little bit easier to see than, say, replacing the make latte with the print statements. I mean, we could obviously done that. We could have put all these print statements in here, but you see, the piece of code right here makes it really, really easy to understand. In fact, if you don't see these other instructions, that would be cool because, well, now it's just an abstract thing. Unfortunately, if I remove it, well, then nothing absolutely works. So unfortunately, we do need to see it. But functions are really, really, really critical. Okay, what you do is you define them, and then later you make use of them. Earlier, I showed you some of the work that I do. For example, I've got this function right here called process batch. And what I do is I'm processing a batch. What batches? Well, somewhere down here, you see, I'm calling batch, batch, batch. Here we go, process batch, process batch. You see, the idea is that I'm trying to make this part of the code simple to understand. Okay, I know it's a little bit weird because it's got a lot of stuff, but can you imagine if I took all of the stuff right here about process batch, sorry, not that one, and I were to replace that single line about process batch with all this? Well, unfortunately, it's going to be pasted here and it's going to be harder to understand what's going on. And it would also be pasted right here. So it'd be duplicated. Perfect. So process the batch here, process the batch here. I won't explain what this is doing because it's outside the scope. But yeah, I use functions all the time in order to make life much easier. You can see, for example, right here, here's one, zip data.open. What's this doing? Well, this is actually downloading a zip file and opening it up. That's actually what this is doing. And yeah, this is one of these built-in things from ZipFile. Well, it's a library. Okay, it was a second class as opposed to things like prints. Do I have any prints? Okay. Oh, but I do have a length, different color in this editor. I do have a print. So yeah, I've got all of these types of things. I've got the built-in ones. I've got the modules that I'm bringing in. And of course, I'm making my own. Why am I making my own? I'm making my own to make things easier to understand. Like, for example, here's how I get data sets. Okay, to get the data sets, I got to go to D2L. I've got to do a whole bunch of weird stuff. I have to use this thing right here. Again, I won't talk about it. How do you transform entities? Okay, well, it's very, very complicated. But the idea is later, when I want to transform the entities, see right here is just transform entities. I don't need to go and understand what's going on. I just call transform entities. This is how you make your programs much easier to understand. All right, back over to Python that we're dealing with. You see, what I'm doing is I'm making this part of the program easier to understand. What am I doing? I'm making 10 lattes. And it's very, very clear what I'm doing from this code. I like this because if I write a program in such a way that it's easy to understand and I don't need to write comments, well, nobody likes to write comments, by the way, I can kind of avoid writing comments because the code is a lot more easy to understand because I am using it. Okay, sorry, let me get back to what I was up to. Okay, a couple things about this. You'll notice that what's inside the function is here. Now, once again, you guys from C and even Java. So let's go back to a Java example for a second. If I can Control Z. Here you go. If you guys wanted to call one of these, it's public static void make latte. We would use this format. And of course, you use the curly braces and you do whatever you're going to do inside here. Okay. So here we don't have curly braces. We use indentation. So each of these lines is part of the function called make latte. This line right now is not part of the make latte. It's still not part of the make latte. And hey, what happens if I indent twice? If you indent twice, you'll actually get a problem because everything has to be lined up. You only use indentation if you're defining a function, you're writing loops, you're using if statements, or maybe some other cases. All right, but in any case, here we go. This is just a convenience at the moment, but it's a really, really good convenience because it makes the program down here easier to understand. We take the complexity, we put it away, we write it once, and then we don't have to look at the complexity again. Okay, so something, of course, that's very important. Okay, I guess I've already done it. In fact, I've already done exactly this. So remember, if I don't call the function, so remember hashtag means to comment out, or let's just not put it at all. This program does not make lattes. This defines a function called make latte, but it never actually happens. It's like having something on your menu that nobody ever orders. So now, of course, I have 10 people ordering it. All right. So next one up. Now, the make latte itself, okay, it's kind of interesting, except you'll notice that it is very specific for exactly one latte. Here, let's just have one because this won't make any sense. Oh, and by the way, if you try to do this, absolutely nothing happens because this function, or sorry, this right here, it assumes because it's indented is inside the function make latte. So yeah, it has to be back here to be part of the main code. All right, so this makes exactly one latte. But what if I want to make two lattes? Is it 6 grams of finely ground espresso coffee? And the answer is no. It's going to take more. Now, in order to make your functions more useful, one of the things that you can do is you can have a parameter. Okay, so what do you have is you have something called a parameter. I'm going to call it num cups. So this is how many cups of espresso I would like to make. Okay, your number of mugs. I think number of mugs sounds better. Do you have espresso in a mug? An espresso mug? Really, I call them cups. Okay, well, whatever you want. It's just a name. Okay, so we will have an espresso number of cups. So not only do I want to make one, I want to make any number. Okay, so here's what we do. You don't take 6 grams. What you do is you take 6 grams times the number of cups. And of course, I'm going to turn that into an F string because it's 6 grams for every cup that you actually want. All right, you don't take 30 mils of water, you take 30 mils times the number of cups. Okay, and again, I'll turn it into an F string. In fact, I'm going to turn each of these into an F string to make it a bit easier. All right, instead of 210 mils, it's 210 times the number of cups. Instead of 180 mils, it's 180 times the number of cups. Okay, and finally with the milk foam, it's not 30 mils, but it's 30 times the number of cups. All right, now watch this. You see, now if I try to call make latte, immediately it says, well, hang on, I don't know how many lattes you're asking for because I need to know the number of cups. In order to fill in a parameter, so the thing up here called num cups is a parameter, what I need to do is I need to put a number. For example, if I make one latte, that's the recipe for making one latte. If I wanted to make two lattes, I could just say make two lattes, and here you go. That's how you make 2 cups of lattes. So all of the numbers scale up automatically. Okay, so now what I've got is I've got a recipe that isn't hard-coded just for a certain size, but by passing in a value, I can figure out any number at all. I've got a big party coming along and I don't know, there's 200, no, let's make it 185. I have to make espressos for, or sorry, lattes for everybody. There you go. That's what it's going to take. It's going to take 1.1 kilos of espresso. It's going to take 5.5 liters of water, 38 liters of milk. Wow, 33 liters of steamed milk. And 5 liters of milk foam. Okay, it's a big operation, but it's really cool because, well, it scales. In fact, if I just wanted to have, like, say, something a little bit bigger, 1.25, so that's 25% more than a regular. Yeah, it even does it. It takes 7.5. It's a really cool way. I can use the same algos all the time, and I can simply change things by passing in a parameter or an argument, sorry, is the actual thing. All right, so this, of course, becomes really powerful because I don't necessarily have to do it for this, but watch what I can do. I'm going to put this one. Okay, sorry. Let's call it make. Okay, let's call it fill order for. Sorry, this is what I get for cups. All right, watch this. Let me remove this for a second. Okay, if I run this, fill the order for 1 cups, fill an order for 2 cups, up to 5. Okay, that's fine. But instead of just saying fill order for this, I'm going to say make latte cups. Now take a look what happens. You see, this is the fill order for 1 cups. This is for 2. This is for 3. This is for 4. I could take this, I could put it inside the coffee shop and print it and say, here you go. Here's how you make for 5, how you make for 4. And yeah, I can run this as many times as I want with whatever values. And of course, I can stick it inside a loop. I can use variables. I don't have to use hard-coded values like I had. Yeah, this is all very, very useful, very, very flexible. Okay, now here's a bit of a problem with this. Okay, although this is one way that we can make lattes, I've got a better way. Okay, I don't mean a better recipe. Sorry, I can't come up with this. I had to Google how to actually make any sense out of this so I could come up with formulas that made sense. But I'm just talking about making the program a little bit easier. You see, well-defined functions should do one thing and it should do one thing well. Now, this is true that the make latte knows how to create a latte. Okay, that's fine. But I would like to make things even more simple. Okay, let's call it this. Required espresso for num cups. Okay, how much espresso do you need for the number for a cup? Okay, well, we had that a minute ago, and I'm sorry, I have to go back because I can't remember the numbers. You see, what we need is we only need 6 grams. Yeah, 6 grams of espresso. Okay, so notice what I've done here. I've returned. Okay, again, you guys have been through some programming courses before, so you know that a return is usually what we end up doing. We don't print things inside functions. Sometimes we do, but this is much more useful because then I can do lots of things. So what I've got is I've got a function called required espresso. All right, and all I'm going to do is I'm going to say, well, it takes exactly 6 times the number of cups. Okay, perfect. So if I wanted to figure out how much espresso, so here we go, I'll call it ESP, okay, for an abbreviation for espresso, is equal to required espresso for 3 print ESP. What's it going to tell me? It's going to tell me 18. So notice what I've done is I've called this function to say, hey, okay, tell me how many things of espresso I require. Oh, remember that there was others. We needed something for water, so I'll call it required water. Okay, num cups. How much water do we require? Well, we discovered that we needed 30 mils of water for each cup. Okay, now, how do you make an espresso or how do you make a latte? Okay, here we go. Make latte. Okay, cups. Okay, yeah, I can use variable names all that I want. Here's what I'm going to do. In order to make a latte, you need some espresso. Okay, how much do you need? Well, calculate the amount of required espresso. Okay, for the number of cups. Figure out how much water you need. So water is required water. Cups. Okay, now I can I can print out some kind of a formula such as espresso, grams of espresso, and print and water ml of water. Now, I know that there's lots of other things, but here we go. We're going to simply say make a latte, and we're just going to say one bang. And of course, yeah, you continue on, you add more things. What I'm doing here is instead of calculating directly within this latte, all that I'm doing is I'm passing off the calculation over here. Why? because maybe this is very complicated. Maybe for 1 cups, it's 6. Maybe for 2 cups, it's not 12, but maybe 11 makes a better espresso with two. I don't know. Maybe you need a little bit more. Like for every cup, maybe you need an extra half a gram. I don't know. I'm not saying whether or not the coffee is going to be good or bad this way, but people may have worked out exactly this type of thing. Some things that I do, I actually do some baking, and I know exactly how this works. Sometimes when you double a recipe, you don't just double the amount of flour. It isn't quite doubled, it's a little bit less, or maybe a little bit more. It really kind of depends on the recipe. So there might be more complications in here. Like you might need if statements to say, okay, if num cups is bigger than 5, maybe you have to send back 7 times num cups. Okay. Otherwise, you could return back 6. And maybe you've got weird things like this. So this allows you to simplify this function right here. Okay, that's the whole idea about what I'm talking about, why you'd want to return something. All right, even this one right here, I don't really like printing things. I would actually rather return it, okay, because it's much more useful. Because in the end, we don't know, are we supposed to print something or are we supposed to send it to a browser? You see, here's a little bit of a hint. Okay, you see this application right here. Okay, the one that you're looking at, the Python interpreter, this was written in JavaScript. Okay, most of it's written in JavaScript. And the way how we deal with the output is we don't actually send it to the screen directly. What we do is we pass it over to a function, and the function then puts things together because there's certain special characters that require extra work. And really, if I showed you the code, you'd be quite surprised how much effort that is to make things appear on a screen. And it isn't just a single print. You have to put it, you have to format it correctly, you have to get it into a div, you have to make sure that the div doesn't go too long. If it goes really big, you need to wrap it around. All of these types of things. If you have backslashes, you got to deal with those. It's really quite a complicated thing. And the idea, once again, is you're trying to break your program into a bunch of little tiny functions so that it makes each individual function easier to understand, easier to work with. So you tend not to do calculations directly. You tend to go off somewhere else. Remember my application over here. Remember I had this little thing right here. I've got this. Okay, I think they're going to come in. Let's see. Yeah, okay. Okay. Uh, I guess they really weren't expecting anybody to be here. Maybe this is a good reason why we should finish up early today. Oh, okay. Anyway, they've gone away for now. But here we go. You see, this is a function called data set to table name. Um, yeah, there's nothing magic going on. Okay, there's some weird stuff going on here with some string comp or some list comprehensions and so on. But the idea is rather than putting this complexity down here, this does something that I checked, and then when I was finished with it, I didn't worry about it anymore. Okay, and all of these things are done exactly the same way. This is why you use functions. In the very end, do you see any code in here that's actually executing? This one's, here you go. Yeah, this is the code right here. And it simply bases by calling these functions. I did this to simplify the main program. Could have I made this smaller? And the answer is yes. I could have combined several of these things into even smaller function, or sorry, single line functions to go off and do things. I didn't. You make a call at the end of the day about what point you want to put it. Okay, but it really is, it just depends on how much abstraction you're trying to deal with. Okay, let's get this guy out of here. Let's get back over to this one right here. All right, so this is the one that we just finished up, parameters and arguments. So yes, parameters are placeholders inside a function, and the arguments are the values actually passed in. The arguments could be constants, or in some cases, it could be variables. To be honest, usually it's variables. Okay, but there's a couple of cases where you might be able to use constants as well. All right, the return values for functions, very, very useful, because if something comes back, okay, something comes back, then you can actually reuse your function over and over and over again. You see, printing a result is not that useful. Remember, I showed you how to calculate the square root. Now, if the function to calculate a square root actually printed to the screen, that doesn't mean it can be used for anything. But instead, what it does is it returns something. Now, I see I've got something here. I'd like to go back and like to touch this one. Okay, excellent. If the number of cups is bigger than 5, return this. Look, I'm going to simplify this entire thing. I'm just going to say print required espresso. Ooh, let's call it ESP for espresso. So, okay, it's nothing weird. It's just a name. And I'm going to ask for 2, and I'm going to print ESP. What do we have? It's just 12. Nothing strange about this. How much espresso do we need for -2 cups? Wait a minute. Um, if I run the function, it actually comes -12. Now, this doesn't make any sense because you can't have -2 cups of espresso or of latte. All right. So here's what I'm going to do. I'm going to come in here and I'm going to say if the number of cups is less than 0, I've got myself a problem. And what I'm going to do, and this is a very common approach that we use in the world of Python, is we return the magic word none. Okay, now that doesn't mean 0. That is a special word called none that we can refer to later. Okay, for example, I can say if ESP is exactly equal to none. Notice it's not a string none, but it's none. I can say that there was an error. Okay. Otherwise, I can print out the amount of espresso. Excellent. So we can run that. Now it says an error. All right. You guys from C++, Java, JavaScript, and PHP. Yes, all of you have seen this. Okay, but you've seen a slightly different name. All right, over here, in the world of Java, you guys have seen the word null. Oh, sorry, is it null? Now I can't remember. I think it's lowercase null. If you came from C++, it's lowercase null or uppercase null. If you're coming from the world of JavaScript, it's called undefined or null. Okay. In the world of Python, the same thing exists. It's called none. Okay, and that's it. Oh, you'll notice something very strange about this is, can I have multiple returns in a statement? And the answer is yes, I can. What happens is the very first statement that returns, the rest of the function is now finished. Okay, so what happens, of course, is when I make the function call, num cups is equal to -2, this would be true. As a result, the function returns none, and this stuff right here is completely ignored. This is exactly the same as any other function in any other language that you guys have seen. Okay, let's get back over to my slides. I think we're actually doing pretty good. Then we can take a very quick look at the documents that I was given, and I'll share. Okay, so you can see what I've done here. Oh, this is something I've done a little bit different. This is just an example of returning a value. This person has gone, okay, this is me. Here, let's get rid of the red lines. Here we go. Somebody has has the make latte. We've calculated each of these rather than calculating here. I thought it looked a little bit better. And instead of printing it, I returned it. Okay, why did I return it? Well, again, I don't know if this output is going to an application running inside a terminal or if it's running inside a browser, like for Instagram or whatever. Well, then we can't actually print it. The best we could do is return it and let whoever called it actually display it to the screen because they know how to put it inside divs and so on. All right, good function design principles. A function should always return a single value. Okay, I will show you how to return multiple values eventually. Function should always return the same type of thing in all cases. In other words, you shouldn't sometimes return a string and sometimes return an int and sometimes return a bool. No, it should always be an int or always a string or always a bool. But you have one exception, and that is if you ever want to if you have some kind of an error, you can always return the value of none, but of course without the quotes. Okay, it's not the string. I shouldn't put quotes in this. All right, so improving the design. So here we go. What I've done is I've got those little functions that I started to talk about. You compute the amount of espresso as number of cups. You take the number 6 multiplied by number of cups. Compute in water is 30 for every cups, 210 for milk. And to make the espresso, if the number of cups is less than 1, return none. Otherwise, build up a big long string. And that's what I'm doing here. And eventually return the result. And yes, I could replace the etc. with the other things. Okay. Ooh, okay. Finished. So let me see, at what point am I supposed to be? Okay, and where am I? 6:30 and 6:30, I was supposed to be back here. So I'll just say 630 is my own record, so I can adjust it next time. So I can include extra things. Okay. The extra things I don't want to cover yet because I'll be honest, I don't have the slides quite ready. They're almost ready, but not quite. I got to put in some examples. All right. So here was the deal. I was told after I do the first two classes, as in the first 6 hours, there is a document I'm supposed to give you. And what I will do is I will put it into D2L. First of all, I have to find it. Okay, so it's this one here. Just give me a second, then I'll pop it up on the screen as well, and we can talk about it. Of course, I can't find D2L. Where do we put D2L? No. D2L. Okay, excellent. Slides. I guess this is actually slides and reference. Okay, I don't find it's a really good reference sheet, but in any case, I was told to share this one with you. Okay, so put it into the folder called slides and upload, download. Okay, and Python reference guide. Okay, so this is now here. It's at the very end. I will leave it at the very end, or maybe I'll leave it right here. My idea was I wanted to take these slides and base it upon the Python reference guide, and I'm going to hope that I've covered everything. Give me 1 second, and we will pop it open so I can show you what's inside it. Where will it appear? Okay, excellent. All right, so here we go. Introduction to variables and types. Okay, excellent. So variable assignment. Okay, pretty straightforward. You assign it using an equals operator. Naming rules. No update. Yes, no update right now. How to name things. And as I said, all lowercases. Sorry, it's called lowercase snake format. The basic operators, the plus, the modulo, the times, but I included other ones. We have strings. We have string operations, the plus and the multiplications. Ooh, I didn't cover that one. Okay, well, this is why we do this, is to make sure. Okay, so there you go. This is used to find out whether or not a certain group of characters exists as a substring inside the other one. So, hey, now we got something a little bit different. When we have a for, okay, you wouldn't be able to do this, but you can use an if. All right, and what I'm doing is I'm asking the question, is Ford part of this name? Now you have to be very careful because if I ask the same question right now, is Ford part of the name? The answer is no, because lowercase Ford is not here. Oh, Fobert Ford? Okay, well, maybe. All right. So what you might need to do is you might want to do something like this, because remember, this would make everything a lowercase, and now it's actually there. So now if somebody types with an uppercase O or D or whatever, I'm making it lowercase first, and I'm asking the question. Okay, so sorry, that's an in. All right, we covered index and slicing. That's very good. We've covered input and output. Yeah, okay, no problem. I've covered a lot more than that. We have loops. We certainly covered while loops. We covered counted loops. We covered sentinel loops. You can see it's the same format. I didn't make this up, but it's the same format that we always teach. We've covered for loops with a range, a start, a stop, a start, a stop, and a step. These are all very, very straightforward things. We've got conditional statements in here. We've got ourselves a break and a continue. So remember, a break will break you out of the loop. A continue will go back to the beginning of the loop. Excellent. Practical examples. Okay, average calculation. I didn't do an average calculation because I knew it was here. But, oh, what? No, 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 no. Why have they put this here? I don't know who made this up. Uh, no, we haven't done this yet. This is the next lecture. Ignore this. Okay, file properties. Who did this? Tech. Doesn't say who made it. Okay, sorry. Ignore the average calculator because they're using sum and length and they're using lists. We will cover it next. All right, but this one right here, this is reasonable. Look, for car in Word, you know what this does. Remember, that was the one we had some questions about. So this is going through looking for vowels. Here we go. Here's some exercises. Okay, excellent. So there's some exercises for you guys to try. If you get stuck with these things, by all means, just let me know. I don't have any solutions to them unless, oh, there's solutions down here. Okay, good. Um, but if a solution doesn't work or doesn't make sense, by all means, talk to me about it. And the document, so I'm not sure who made it because it was only the one that was bad. Everything else is pretty decent. Okay, this is good. Sum and average until zero is entered. Okay, excellent. We've actually kind of done exactly that. Okay, so good. We do actually have some stuff. It's just this one right here, 7.1. Please ignore 7.1 because we haven't seen that yet. And yes, that is an array. Okay, we just haven't seen it yet. And is the document in D2L? And the answer is yes, the document is in D2L. It's right here. It's called the Python Reference Guide. You know what? I'm going to put it somewhere else. Python Reference Guide. I'm going to have a separate section called Python Reference Guide. I will put it just after the slides. And I said after the slides. Okay. Python. Hello, right there. Thank you. And I will drag that into the Python reference guide and I will change this and it'll be just called slides. There we go. All right, now if we take a look at our table of contents, all right, now you can see that the slides have the slides, the reference guide has Python reference guide. I will add the second one at the other one. All right, and also in the last lecture, there were questions regarding the exam. I do not have an answer to that, but you know what I am going to do? You wait 2 minutes right now, and I'm going to send a message. Okay, the message has been sent. So, if I don't have an answer for you tomorrow, it's not my fault. You can still blame me, but it's not my fault. I will blame the other person for not getting back to me. I don't know if they will get back to me today. I hope they get back to me before class starts tomorrow because I have a couple of things. So, first of all, when it is, I do not have the time. Okay. I would say just, I would say not to worry about it, but I'll ask, but I think they're not going to answer me because this question was asked. Let me pull it up and see what was said. Schedule and exam dates, because somebody said, please let us know which courses and the exam dates. And they told me, here, I can even show you. Okay, here you go. Stretch this out. Okay, this came from CPE, Continuing Education Department, and it says right here, exam 25th of August, 2025. Dates of training 3, 4, 5, 6 August. Well, I guess we're number 4. All right, let's see. Do the next one. Advise. Where did this go? Okay, unfortunately, okay, so I remember, okay, so here we go. We did have this comment right here. It's so there was this message, and I'm sorry if you got this one. It said that the exams will be online on the 25th. That's not true. We did get a clarification saying that it will be in person. Okay, I can't find the email that it goes with. And I know that they said that some students might be involved in more than one of these courses. So we'll have to figure out exactly a decent time. Now, I suppose what's probably the most fair thing to do is to try and fit this into the evening, like between is 4 o'clock to 8 o'clock, like this type of thing. I'm not saying that's when it is, but I hope that they will continue. But in reality, since this is kind of prep for the upcoming semester, the very next day, well, that's when classes begin. And I don't know what they're doing for your program in terms of scheduling, but there's an expectation that it would probably be during the day. That's my guess. I don't know because I'm not involved with your program. So unfortunately, I don't think I'm actually going to know the timing of this exam. The location will be in campus. That's no problem. So where it is, no problem. It's here in campus. I don't know which room yet, but I will definitely let you know. And maybe we have to be a little bit flexible with people, and maybe some people can come in one time, and maybe some other people can come in. I don't know what they're planning on doing because I'm not the person who organizes this. So as soon as they communicate with me what time it is, I will definitely let you know. I've got a message sent off now to the person who was supposed to teach the course before. So there's the person right there. It's Saifuddin, asking him for a copy of the previously used exam so that I can keep it exactly the same, or at least very, very close. Okay, so that'll be the format. So I'm sorry I don't have a time. I've got a date, 25th of August. That's not a problem. Location on campus, but I don't have a time yet. Okay. And unfortunately, I'm probably not going to have a time until another couple of weeks. But you can see as these other courses get finished, there's definitely going to be a lot of stuff going on where somebody says, hey, we need to know the exact timing. But I know that there is a talk because some people might be taking more than one course. And obviously, we can't make you do two exams at the same time. It might have to be one after the other, but we can't make you do two at the same time. Okay, so I'm sorry, I don't have an answer to that yet. Okay, but if I can get at least the format for tomorrow, I will be quite happy to do that. All right, so let me see here. Final thing then, I'm going to do this right now. We're going to pause the recording. I'm going to stop the